Hello students, welcome back to the engineering physics lab session. Today's our experiment is laser diode characteristics, and the aim of the experiment is study of VI and PI characteristics of the given laser diode. So today's our experiment is laser diode characteristics, and the aim of the experiment is to study the VI voltage versus current and PI power versus current characteristics of the laser diode. And to do this experiment in our lab, we are using a micro laser diode characteristic board. So this board consists of the devices like voltmeter, which is connected internally on the kit itself. Voltmeter is used to measure the voltage, and these are the terminals of our voltmeter. Red indicates positive, black indicates negative. And this is the ammeter, which is used to measure the laser diode current here. And these are the terminals of our digital ammeter. Again, this red is positive, black is negative.
3.
And there is a wattmeter, which is used to measure the optical power. And these are the terminals of our wattmeter. Red is positive and black is negative. So along with that, we have various resistors over here. One is 100 ohm and 150 ohm, 220 ohm, and also we have 1 kilo ohm variable resistor. While connecting the circuit amongst all the 4 resistors, you can use any one. Always we go with the least value of resistance. Coming to the another device called our laser diode. This is the laser diode whose terminals are here. Red indicates positive, again black indicates negative. And we have 0 to 5 volts variable DC power supply. These are the battery terminals. Red is positive terminal, black is negative terminal, and it is a variable power supply. That is the reason they have connected the knob here. So between 0 to 5 volts, you can rotate this knob whichever the value of voltage you require. And the another device is here, photo detector, which is placed exactly opposite to your laser diode. And this photo detector is used to the role of this diode is used to detect the light, and which converts the equivalent light energy into electrical energy, and that power can be seen with the help of this wattmeter, which is connected to this optical power meter called our wattmeter. Right. So let me come back to the circuit. So this is the circuit diagram to study the VI and PI characteristics of our laser diode. So let me start with the starting point. This is our DC battery eliminator. This large terminal indicates positive, short plate indicates our negative. So take the connecting wires. So these are the connecting wires to connect all these devices. With the help of these connecting wires, from the positive terminal of this battery to we are giving to any one resistor first terminal. I am using here 100 ohm. Now the second terminal of my resistor to connect the first terminal of your milliammeter. From the milliammeter negative terminal to we are giving to the laser diode positive terminal. From the laser diode negative terminal to I am connecting to my battery negative terminal. So this is what the circuit, and after that we are connecting our digital voltmeter, which is parallel to your DC battery eliminator. So parallel connection is here, positive terminal of the battery to positive of the voltmeter, negative terminal of the battery to negative terminal of the voltmeter. So this section is used to study the or measure the VI characteristics of our laser diode. Now coming to the another rest part of our circuit, which includes 2 more devices which we have already discussed about, photo detector and wattmeter. Again, these 2 devices are connected in parallel. The positive of the photo detector is connected to positive terminal of the wattmeter, and the negative terminal of the photo detector is connected to negative terminal of the wattmeter. And this detector will detect the light energy, and it converts into optical power, which can be measured with the help of this wattmeter. Now let us connect the circuit with the help of that diagram. Okay, let us start our circuit diagram connections. So from positive terminal of our battery eliminator to resistor first terminal. So I have taken a connecting wire. So from the positive terminal of my 0 to 5 volt DC battery eliminator to I am giving to the first terminal of my 100 ohm resistor. This is what your first connection, right? Now from the second terminal of your resistor to positive terminal of your milliammeter. See, from the second terminal of our resistor to positive terminal of our milliammeter. So this is our second connection. Coming to the third one, milliammeter negative to, it is coming to laser diode positive, right? So milliammeter negative to, these are our laser terminals. The negative of the milliammeter is coming to positive of our laser diode. Now from the negative terminal of our laser diode to, I am closing the circuit to the negative terminal of our DC battery eliminator. So negative terminal of the laser diode to negative terminal of the DC battery eliminator. So this is the first part of our connection. Now let us see this parallel. So for this parallel, what we have to do? We need to connect positive terminal of the battery to the positive terminal of the digital voltmeter. This is our digital voltmeter and this is our battery. See, parallel connection. Again on this DC battery eliminator, positive to positive of the voltmeter and negative of the DC battery eliminator to negative of the voltmeter. This is called our parallel connection. The parallel is between digital voltmeter to DC battery eliminator. Okay, and coming to the PI characteristics part. For that, we are connecting parallelly between photodetector to wattmeter. So this is our photodetector. These are the terminals. So the positive terminal of the photodetector to the positive terminal of your wattmeter. This is your first connection. Positive of photodetector to positive of wattmeter. Now negative of the photodetector to negative of the wattmeter. See, negative terminal of the photodetector to negative terminal of the wattmeter. So these are the parallel connections between detector to the wattmeter. So this is about our circuit diagram. Now let us start to take the readings. For that, first after ensuring all the connections, you need to switch on your kit. So after switch on your kit, firstly we are taking the readings for voltage versus current. Voltage value you can measure with the help of this digital voltmeter and current values you can take with the help of this digital ammeter. So we call it as VI characteristics, right? So this is the required tabular column for the VI characteristics, and I have 0 to 5 volt battery DC battery eliminator here, which is a variable battery eliminator. So I am just taking the readings by following 0.5 calibration scale. The difference between one reading to another reading, I am following 0.5 volt. Like that, I am going to fix my voltage values in the digital voltmeter by using my DC battery eliminator. So like this, I am going to take my voltage readings. Firstly, I am noting down that scale here. I am going with the 0.5 voltage difference between one reading to another reading, and you have already seen the battery eliminator whose maximum is 5 volt. That's why I am going till 5 volts by taking 0.5 volt difference. Right. So now with the help of this knob, first I am going to adjust the value of voltage in the digital voltmeter. Firstly, I will start with 0 voltage. For 0 voltage, I need to measure the current in the digital ammeter. For 0, the current is also 0. Now, I am going to with 0.5 volts. So, by placing the 0.5 volts in my digital voltmeter, I need to take the current reading in the digital ammeter. At this value of voltage, the current still it is 0 in the digital ammeter. Now let us go for, as per our calibration, let us go for 1 volt in the digital voltmeter. For 1 volt, so still I got 0 in my digital ammeter. There is no variation in the current of our laser diode. Now let me take for 1.5. So when I place 1.5 volt in my digital voltmeter, still the ammeter is showing 0 milliamperes. The current is not yet started in the case of your laser diode. Now, as usual, as per my calibration, I need to go with the 2 volt, but in between that I just observed for 1.52 volt. For 1.52 volt, I got 0.01 milliampere current in my digital ammeter. So this voltage I call it as threshold or operating voltage of my laser diode. So with this value of voltage, this laser diode is conducting the electricity. Right, now as usual I will go with the same scale. So now I will place my value of voltmeter to 2 volt. So from here onwards, as you are increasing the voltage, the current in the laser diode will also increases. You can observe the ammeter here. As I am increasing, the current is also increases. So now I will place for 2 volts. So for 2 volts, I got 0.86 milliamperes. Again for 2.5. Again for 2.5 when I am taking. So I will get, so I got here 2.58 milliamperes. Now again for 3 volt. For 3 volt, the current in the ammeter will be 4.37 milliamperes. Again for 3.5. Again for 3.5, the current is 6.20. Now for 4 volt. So for 4 volt, it is 8.03. For 4 volt, it is 8.03. Now again for place the value of voltage for 4.5. So for 4.5, I got 9.92 milliamperes in my digital ammeter. Now I will go with 5 volt. So for 5 volt, it is 11.82. For 5 volts, the digital ammeter is showing 11.82 current. Again, actually my maximum value of voltage is 5 only, but it goes up some approximately 6. So I also take for 5.5. So for 5.5, it is 13.64. So this is my maximum voltage. This is my maximum voltage as per my variable DC battery eliminator, as per my source. So for this maximum value of voltage, I got 13.63 to 64, approximately 13.64 milliampere current in the digital ammeter. So this is about the VI characteristics readings. So after taking these readings, we need to plot the graph. So to plot the graph with respect to your minimum and maximum values, by following these minimum and maximum values of both voltage and current, you need to take the scale. You need to take the scale approximately. So I will take my voltage value on x-axis and current value on y-axis. So I have taken in my, these are all already I have taken readings. For those readings I plotted the graph. So as per my readings, I have taken my x-axis voltage difference will be 0.2 like that, and on my y-axis current reading difference will be again 0.2 milliampere, like that I have taken with respect to my taken values, and I have plotted the graph. So in this graph, when you observe, from the starting value of voltage, the current is 0, but at one particular value of voltage, you can find the current is started in the laser diode. So this particular value of voltage, you call it as threshold voltage or operating voltage of the laser diode. From this voltage onwards, as you are increasing the voltage, the current in the diode is also increases. So this is the VI characteristics behavior of our laser diode. So this is what my scale here. On x-axis I have taken each block. We call it as 1 unit is equal to 0.2 volt. And on y-axis 1 unit is equal to 0.2 milliamperes. This is what the scale which I have taken while plotting this graph. Now we will take PI characteristics of the power versus current characteristics of the laser diode. So we will measure current as usual with the help of same ammeter and power with the help of wattmeter. So how to take the current readings? In the earlier you have measured voltage versus current. So when you are measuring voltage versus current, you have rotated the DC battery eliminator knob. By rotating this knob, you have varied the voltage and you noted down the current which is flowing through the diode. Now what we are doing, with the help of same knob, by rotating the same knob, you need to note down the current in the digital ammeter. With respect to that current value, we are going to find the power, optical power in the digital wattmeter or power meter. So for that we are also rotating the same knob, and before that, before going to start to take the readings, so let us see this meters. See, in your ammeter there is no current flowing in the diode, it is showing 0. But when you observe your power meter, there is some value, it is showing some value. Why that value is coming? There is no current in the diode, but the power meter is showing the reading. Why this value is coming in the power meter? Because this is the, what is this device? We call it as a photodiode or a detector. This detector role is to detect the light, and it converts the light energy into equivalent electrical energy. But there is no current in the diode, there is no light in the diode, but this detector is capturing the outside light of our lab, and it is converting our outside light into electrical form, optical form. Right? So that is the reason you are getting. For suppose if I closed this part, this photo detector, see, now you can observe in the wattmeter it is also 0. Right? So in such a case you need to follow the point here. Only this detector has to capture the light which is coming out from the laser diode only. For that we are just closing the two devices with the help of a piece of paper. So when I closed this piece of paper, this detector now, it is not capturing the outside light. Hence you don't have any value in the optical power meter, right? So now when you operate your DC battery eliminator, then the current will flow in the diode. That value you can see in the ammeter. With respect to that power, you can able to see in the wattmeter. For that purpose, I have covered my detector with the help of the piece of paper. Now again coming to the calculation readings part. So again I am just going with the 0.5 scale, 0.5 milliampere scale. We are taking current versus power here. So every 0.5 milliampere current, I am going to note down the power value in the wattmeter or optical power meter. So I have taken same 0.5, 0, 0.5, 1, 1.5 like that. So again with the help of this DC battery eliminator, I am going to rotate the knob. Firstly I am going with 0 value of current in the digital ammeter. For 0, the power meter is showing 0. For 0.5. So to get the 0.5 current in the diode, that means in the digital ammeter, I need to rotate my knob of DC battery eliminator. So until I get the 0.5 value in my ammeter, right. Now in the digital ammeter you can see 0.5 milliamperes current, and with respect to that value the optical power in the wattmeter should be 0.1 milliwatts. For 0.5 milliamperes you got 0.1 milliwatts power. Now let's go for 1 milliamp current. By using that knob, again place the 1 milliampere current in the milliammeter. With respect to that current, note down the power in the wattmeter. It is showing 0.4 milliwatts. Now as usual scale, again I will go with 1.5 milliamps. So for 1.5 milliamps, for 1.5 milliamps I got 0.6 milliwatts optical power. 1.5, 0.6 milliwatts. Again go for 2. For 2 milliamperes the wattmeter is showing 0.9 milliwatts power. Now let's go for 2.5. So for 2.5 milliamperes current in the ammeter, the power should be 1.2 milliwatts. Now let's go for 3. For 3 milliamperes current in the ammeter, the power is increasing 1.5, right? Now again for 3.5. 3.5, the wattmeter is showing 1.8. As the current increases, the power in the optical power meter is also increases. You all know about the relation. Power is directly proportional to the I square. You have studied that formula in your intermediate. So with respect to that formula, as the current increases, the power in the wattmeter is also increases, power meter. So now for 4 milliampere current, I got 2.1 milliwatts. Next I will go with 4.5. So for 4.5 I got 2.5 power. 2.5 milliwatts power. Now go for 5. For 5 milliamperes current, the power is 2.9. Next go to 5.5. For 5.5 milliamperes current, the power is 3.3 milliwatts. So we will go for 6 milliampere. For 6 milliamperes current, you got 3.9 milliwatts. 3.9 milliwatts. Now for 6.5. For 6.5, the power value in the optical power meter is 4.4 milliwatts. Now go for 7 milliamps. So for 7 milliampere, the power is here 5 milliwatts. Next for 7.5. 7.5 milliamperes current, you got 5.4 milliwatts. Next for 8. For 8 milliamperes, the power is 5.9. Next for 8.5. So for 8.5 milliamperes, you got 6.4 milliwatts. 6.4 milliwatts. Next again place the current value for 9. For 9 milliamps, the power is like 7.2. Next for 9.5. So we are going with the 0.5 scale. So for 9.5 milliamperes, current is here 7.5. Next go for 10. Slowly rotate the knob. Yes, I got 10 milliamperes in the ammeter. The power is here 8.6, sorry, 8.6 it is showing. 0.6. Now go for 11. 10.5. So for 10.5 milliamperes, you got 9.2 milliwatts. Next, the reading will be for 11. So slowly you need to rotate the knob. Yeah. For 11 milliamperes you got 10.1 milliwatts. Next reading for 11.5. Yeah. For 11.5 milliamperes the power is here 10.8, increases 10.8. Next reading will be for 12 milliamperes. So for 12 milliamperes the power is here 11.4. Next reading for 12.5. For 12.5 milliamperes the power is 12.3. Next we will go for the next reading 13. So for 13 milliamperes the power value is almost 13.4 milliwatts. Next reading will be for 13.5. So for 13.5 milliamperes of current you got 14.5 milliwatts. Next reading, like that you need to go for the maximum value of current in the diode. See, the maximum is, it is going up to 14. So this is what my last reading. For 14 milliamperes current I got 15.1 milliwatts. So this is the maximum current in my laser diode with respect to the voltage which I have supplied. So these are the values for power versus current characteristics. We just followed with respect to 0.5 difference scale. So as the current increases here, the power is also increases. So for this also we need to plot the graph. So for that graph I have taken the current I value on the x-axis and the power value on y-axis. So this graph we have already drawn with respect to our previous readings. So with respect to our previous readings we have plotted this. So here I have taken as usual 0.2 difference scale on my x-axis and 0.5 milliwatts difference scale on my y-axis. I have pointed all the points, then after joining all these points I got the curve like this. So same behavior you have seen as the current increases, the power is also increases. See, this is the required plot for the PI characteristics of the laser diode. So at last the conclusion. So with respect to this 0 to 5 volt DC battery eliminator, so this is the maximum voltage I have given to my kit. So with respect to this voltage, this is the maximum current which is conducting inside the laser diode, and this is the light which is coming out from the laser. So this is the light which is coming from the, see here, the spot is on my finger. So this is the laser light which is coming out of the laser diode. When this light is falling on this photodiode, this diode is detecting that light and it is converting into its equivalent, that intensity into its equivalent optical power, and that power is measuring with the help of this optical power meter. So this is about your VI and PI characteristics of the laser diode.